Question 10a. Three spheres A, B, and C with the same charge positive Q are placed along a straight line as shown below. What is the net electrostatic force acting on sphere B? So here we have three spheres A, B, and C which carry the same charge positive Q, and we need to find the net electrostatic force on sphere B because of A and C. So let us first find what is the direction of electrostatic force on B because of these individual spheres. Since both A and B are positively charged, B will be repelled away from A, and electrostatic force because of A on B will be towards the right. We can call this force as FAB. B and C are also positively charged, so B will be repelled away from C. And because of C, B will be pushed to the left, and we can write this force as FCB. The net electrostatic force on B will be a vector sum of these two forces. And when we say vector sum, we have to take the direction into consideration. So the forces going to the right will be taken positive. So here FAB will be positive. The forces going to the left will be negative, so we have to subtract FCB. Then let's substitute the rule for the force. We can write FAB as K QA QB over RAB squared, where QA and QB are the charges on sphere A and B, and RAB is the distance between them. So this is RAB, which as you can see from the figure is equal to A. Minus K QC QB over RBC squared. QC, QB again are charges on sphere B and C. RBC is the distance between them, and we can find their distance by subtracting these two values. So 3A minus A, which is 2A. So now let's substitute K, we can take it out as common. QA and QB both carry the same charge, so we can just multiply them and take it as Q squared. RAB is A squared minus QC and QB again same charge, so we can write it as Q squared. RBC is 2 times A, the whole squared. That becomes equal to K Q squared over A squared minus Q squared over 4A squared. Now we can take Q squared over A squared also as common out. So K Q squared over A squared, and you are left with 1 minus 1 over 4. That gives you the net force to be equal to 3KQ squared over 4A squared. And since this force came out to be positive, it will be directed towards right. And it makes sense because sphere B is so much closer to sphere A. So the force of repulsion due to A will be much stronger than the force of repulsion due to C, as they all have the same charge, but C is further apart compared to A and B. In part B, we have a similar case. The only difference here now is sphere B carries a negative charge. Equal magnitude, but the sign on the charge is negative. So all the three spheres A, B, and C carries a charge of magnitude Q. A and C are positive, B is negative. So again, we start by describing the direction of force on sphere B because of A and C. Since B is negatively charged, A is positively charged, B will be attracted towards A. So force on B because of A, will call this force FAB. C is also a positive charge, so B will be attracted to C as well. And because of C, B will try to go to the right. We call this force FCB. Distance between A and B, we call it as RAB, which is equal to A. And distance between B and C, we call it as RBC. And this distance is 3A minus A, which is 2A. Then we do the similar calculation. If I have to find the net force, I need to take vector sum of these two forces. And when we take vector sum, we take direction into consideration. Force going to the right, which is FCB, will be positive. Force going to the left, which is FAB, will be negative. Now substitute the rule. KQCQB over RBC squared minus KQA over RAB squared. Now, when we are substituting the magnitude of the charge, we do not take the negative sign. We only substitute the value. The direction here is already taken care of by the vector sum, so I will not put the negative sign on sphere B. We will just take the magnitude, which is Q. So let's take K as common again. Both QC, QB has the same magnitude of charge, so it becomes Q squared over RBC is 2A. 2A squared will become 4A squared minus Q squared over A squared. Again, take KQ squared over A squared as common out, and you are left with 1 over 4 minus 1, which gives you negative 3KQ squared over 4A squared. And this force is negative because it is going to the left. So I can write the net force to be equal to 3KQ squared over 4A squared going to the left. Again, it makes sense that the net force will be towards the left because if each of the sphere carries the same magnitude of charge, the two spheres which are closer to each other will have greater force compared to the one which is far from each other. Therefore, force due to A on B is greater than force due to C on B, and the net resultant force will be in the same direction as FAB. Next, in part C, we have three charged spheres, again A, B, and C. A is now negatively charged and has a charge of magnitude 2Q. So charge on sphere A is minus 2Q. B and C both are positively charged and they carry the same charge, which is plus Q. And we need to find what is the net electrostatic force acting on sphere C. So we start with the same process. We first find what is the direction of force on sphere C because of A and B. Now let's start with A. A is negatively charged, C is positively charged. So there will be a force of attraction between them. So C will move towards A because of this force. So the direction of force on sphere C because of A will be to the left. We will call this force FAC. Then B is positively charged, so it will try to repel C away from itself. So direction of force on C because of B will be to the right, going away from sphere B. We call this as FBC. Distance between A and C is 3A, whereas distance between B and C is 2A. We just subtract these values and you will get the distance. So now let's calculate the net force. The net force on sphere C will be a vector sum of these two forces. So when we take vector sum, we will take the direction into consideration. FBC is going to the right, so we will take it positive. FAC is going to the left, so we take it negative. Now substitute the rule. KQB QC over RBC squared minus KQA QC over RAC squared. QA, QB, QC are charges on the respective spheres. RBC is the distance between sphere B and C, and RAC is the distance between sphere A and C. Now let's substitute. You can take K as common. QB is Q. QC is also Q, so you can just take this as Q squared. RBC is 2A squared minus QA is negative Q, but when we are substituting the charge in the rule for force, we don't take the minus sign. The direction is taken care of by the vector sum. I will just put the magnitude. Do not put the minus sign on the charge. So we write this as 2Q into Q over 3A squared. So that gives you K Q squared over 4A squared minus 2Q squared over 9A squared. So let's take Q squared over A squared common out. So K Q squared over A squared, you get 1 over 4 minus 2 over 9. Now while solving in exam, you can find this sum in the calculator. and then substitute. So we get this as kq squared over 36a squared. The force is positive, therefore it will move to the right.